Hello students. In this semester, I will be going to deal with your subject computer organization and architecture. Before getting into the subject, let us see that what is the course objective of your subject. So in our subject, the first course objective is nothing but implement the fixed point and floating point addition, subtraction, multiplication and division. What actually you mean by this? When you go with your system computers, blindly you will be typing some number to perform some addition, subtraction, multiplication or division. Okay, and you will be getting the results on your system. Okay, it can be your normal fixed point or it can be a floating point. So how internally, where in the system internally, how it is going to perform the addition, subtraction, multiplication and division? What is the algorithm it is going to use? What are the different steps it is going to perform? That we are going to see in our first course objective, and this first course objective will be dealt in our first unit. Coming to our next course objective, which is nothing but to describe the basic structure and operation of a digital computer. So here we will be going to see which you have already studied from your childhood. That is nothing but your Coming to our second course objective, which is nothing but your describe the basic structure and operation of a digital computer. This particular part which you have already studied from your school life. In the school days you have seen what is digital computer, what are the different parts of your digital computer, okay, and what is the internal structure, little bit you will be going to have an idea. So that thing we will be going to discuss in our second course objective. Apart from that one, we will be going to see that internally how it is going to have the connections have been organized, how it is been organized, how the communication will be dealt from one part of your system to other part of your system, how it is been done. So that we will be going to deal in our second course objective. Coming to our third course objective, discuss the different ways of communicating with I/O devices and standard I/O interfaces. So, in the second course objective, what we have studied in what is a digital system, digital computer system, what is the internal basic structure is available. Okay, how we are going to communicate, how the each and every part is been organized, and how it has been going to communicate with each other. Now, in the third course objective, you will be going to study that what are the input and output devices are there, how these input and output devices are been communicating with your system. Some certain protocol should be used for communication. Like for example, if I know only English and you people know only Hindi, so if I say hi, will you be in a position to answer to my hi? Will you be replying to my hi? No, that is nothing but it is not a good communication. If you understand my way of talking, that is my language, and your language, if you are going to your language, if I am going to understand, then only the communication can be possible. In the same way, when I talk with my input and output devices, each and every input and output devices will be having its own way of communicating. So that communicating should be understandable by your system. At the same time, the system will be going to in return will be going to reply to that particular device. So that device should also understand that what is system is been replying. So for that case, we need to know that what type of interfaces we'll be going to use and how it is which protocol, by using which protocol it is been going to communicate from the system to the I/O devices. That will be covered in your third unit. Coming to our fourth course objective, which is nothing but to analyze the hierarchical memory system, including the cache memory and virtual memory. So in this case, you will be going to see that memories. Memories is nothing but cache memories you will be going to have, and you will be going to have the virtual memory. So how you are going to use this cache memory or virtual memory? How the system will be going to act? If at all if you are using these memories, what is the advantages? Okay, and what is a different memory architecture? You are going to have different hierarchical architecture. You will be going to study this in your fifth unit. Coming to a fifth course objective, which is nothing but to understand the issues affecting the modern processes. So in the modern existing processes, there are certain issues are available. What are those issues? How it has been affecting that our processor system, that you will be going to study in your fifth course objective. Okay, so these are nothing but your some of the course objectives which are available. Coming to our course outcomes, at the end of our complete subject, you should be in a position to be able to answer these particular course outcomes. Coming to our first course outcome, perform the mathematical operations on fixed and floating point digital data. As I have already told you that in our course objective, we will be going to study in the first unit fixed point and floating point representation, and how the basic mathematical operations, that is nothing but your addition, subtraction, multiplication and division will be performed, okay, on digital data. What type of algorithms we are going to use, that we have studied in our first unit. Using the same algorithm, I will be going to perform using that algorithm. I will be going to perform a certain mathematical operations. Like I will be saying that 2 plus 3 is equal to 5. By using that algorithm, how we will be getting 2 plus 3 is equal to 5? We will be going to see now. You should able to do that by using that algorithm. That is nothing but your first course outcome. Second is nothing but illustrate the operation of a digital computer. So that means that what is the internal structure of your digital computer, what are the various blocks are there, how each and every block will be going to have internally how it is been programmed, how it is operating. So those things you should be have an idea, that we will be going to study in our second unit. Okay, understand the IO interfacing of a computer. Just now I have told you, when an input and output devices is been connected to a system, what type of interfacing is there, how protocols will run, that things you should have a clear cut idea. So you should be in a position that if I give you some input device like keyboard, you should be in a position that how the system, when I press A, how that system will display A on my output device will monitor A, how it is going to, how the communication takes place. Okay, that you should be able to explain. Coming to the fourth one, interfacing the microprocessor with the memory devices. A microprocessor is nothing but you will be in a system, you will be having a processors, Intel i3, i10, i4, 5. These processors are nothing but your microprocessor. So these microprocessors, how we are going to interface to your memory device. What are my memory devices? Our memory devices are RAM memory, ROM memory, external hard disk, CD-ROM, floppy disk. So these are different types of memory devices. We are going to have pen drives. How it is being interfaced to your microprocessor, that you should be have an idea. After going with your fifth unit, for completion of your fifth unit, you should be in a position that how the data will be transferred from processor to the memory or memory to the processor. And the last is something about your understanding the latest trends in microprocessor. Understanding the latest trends means what is the latest technology has been implemented, how it is been implemented. Those things you should be knowing an idea about that one. So these are nothing but your different course outcomes of your subject. Let us get into the syllabus one by one. Coming to our syllabus, unit 1. In our unit 1, we will be going to come across with two parts. One is nothing but your data representation, and the second one is nothing but your computer arithmetics. In the data representations, we will be seeing that how the data will be represented in. Okay, and before getting into the data representation, we will be studying the main important thing is nothing but introduction to the computer system. What is a computer block diagram? Okay, what are the various parts are there in the computer system, that we will be going to study. And apart from this one, we will be going to see that what is organization and architecture. According to our syllabus, what is our syllabus? Our subject is computer organization and architecture. So computer organization and computer architecture seems to be same thing, but there are very slight difference is there between these two terms, and it is very important question for your final exam. Damn sure question in your final, that is in the SAQ, he will be asking you difference between the organization and architecture, computer organization and computer architecture. Okay, that we will be going to see in our first unit. Later on, we will be going to see the what is the evaluation, different computer generations are available. That we will be going to see as one part of our first unit. In the second part, we will be going to see two types of representations, that is data representations. One is fixed point representations and the second one is nothing but your floating point representations. Okay, so how we are going to represent fixed point, how we are going to represent the floating point, we will be going to see those things. After that, in fixed point, what are the different digital arithmetic algorithms are there to perform addition, subtraction, multiplication and division. Okay, what are the different types of algorithms are there, that we will be going to see for each operation. Later on, we will be going to with the floating point representation with IEEE standards. We will be following IEEE standards for representing the floating point representation and its arithmetic operations, that is nothing but your addition, subtraction, multiplication and division algorithms we will be going to study in our floating point representation. So in syllabus unit 1, we will be going to see the basics of our computers. Then we will be going to with the data representations, fixed point representation and floating point representation. Later on, we will be going to cover with the computer arithmetics. So in the computer arithmetic is nothing but addition, subtraction, multiplication and division. What are the different algorithms are there? We will be going to see that in our first unit. Coming to our second unit. In our second unit, our main intention is nothing but your basics of your computer organization and design. So what is organization and how it has been designed? Okay, that we'll be going to see. So in that, we'll be going to come with your instruction codes, store program organization, what are computer registers, and what is common bus system. This common bus system is also one of the important question for your final exam. Okay, what is the computer instructions, timing and control signals. Okay, what is instruction cycle, fetch and decode, what are the register reference instructions, what is memory reference instructions, what are input, output and interrupts, configurations, how input and output interrupts has been configured, what are the instructions for interrupts, program, what is program interrupt, what is interrupt cycle. Okay, later on we'll become with the next part of our second unit, which is nothing but your micro programmed controlled organization. What is address sequencing, what is micro instruction format, and next one is your micro program sequencer. Okay, so basically first part of your second unit will be dealing with your computer organization design part. In the second part, we will be seeing that micro programmed control organizations. Okay, in the first part will be on the store program organizations. The second second part is nothing but your micro programmed control organizations. So it is very important for your final exam. From this unit, you will be damn sure you will be going to get 2 LAQs. So concentrate in your second unit. Coming to our third unit. In the third unit, we will be going to see the one of the block, which is nothing but your central processing unit. What is, what is central processing unit? In that, what are the different general registers, or how the general registers have been organized, how the stack is organized, what are the different instruction formats are there, what do you mean by addressing modes, what are the different types of addressing modes are there, that we will be going to see as a central processing unit. Later on, we will be going to come with the next topic, what is RISC and CISC architecture. Okay, these are now two different architectures are available. Instruction set architecture is available. One is complex instruction set computer, and there is nothing but your reduced instruction set computer. So what are the features are there, and what is the comparison between RISC and CISC? So later on of this unit, you will be going to study pipelining concept and vector processing. Okay, in the pipelining, how we are going to have a pipelining, how we are going to implement the pipelining concept, you are going to study. In vector processing, actually you do have vector processing and array processes. So both you are going to study in this thing. So from the third unit, we will be going to see in the CPU, how the registers are organized, how the stack is organized, what are the instruction formats and addressing modes. Later on, we will be going to study the RISC and CISC. Next, pipelining, and the next one will be your vector processing and array processing. Coming to our fourth unit. In the fourth unit, we will be going to concentrate on our I/O organizations. I/O organization is nothing but how you are going to interface your input and output devices. What is the bus we are going to use to transfer the data. Okay, what is the interface module we are going to use. Okay, what is the difference between the input and output bus and memory bus? What is the difference between those things? Next one is nothing but what is asynchronous data transfer, what is synchronous data transfer. Okay, so there are different modes of transfers you are going to have. Okay, and what are the different modes of transfers are nothing but your programmed IO, interrupt driven IO, priority interrupts, desi chaining interrupts, parallel priority interrupts, direct memory access, DMA controller and transfer, and IO processor. So in this mode of transfer, you are going to study. First mode of transfer will be related with your IO device, and the second mode of transfer is related with your memory, which is nothing but your DMA. DMA is also one of the important for your final exam. Coming to our next one is CPU and IOP, communication and IO channel. Okay, so how you are going to do the communication between the CPU and the IO, that we will be going to see in our fourth unit. Coming to our fifth unit. In this fifth unit, we will be going to see that what is memory organization, what is memory hierarchy. Okay, what are the different types of memories are there. Primary memory, auxiliary memory, associative memory. Okay, later comes with your cache memory, and next one will be a virtual memory. In that, how we are going to implement the paging concept, how the mapping of your memory is been done, that you are going to study in our fifth unit. So in our out of this one, the syllabus coverage, the best book which you are going to refer for this subject is nothing but your first reference, which is nothing but your Morris Mano by Computer System Architecture, and you are going to use third edition. Don't go with any other edition. You are going to use the third edition, Morris Mano. Okay. In the next class, we will be going to start with our first basics of your COA. Then we will be getting in depth of your subject. Thank you.